Alright, welcome guys. For my starting video, I'm going to teach you about exponential functions. Now exponential functions can either be very hard or very easy. The way that you make them very easy is by memorizing the laws of exponents. Okay, the important thing to note about these laws, the 5 laws of exponents, is that b and a down here are both constants. And what's important is that all the b's for each problem must be the same constant. For example, this for rule number 1, it can't be 3 to the x, 5 to the y, and equals 15 to the something. It must be 3 to the x, 3 to the y, equals 3 to the x plus y. And again, in this case, x and y are other numbers that can be variables. They are the function that you apply. It's also important to note that these rules can go back and forth, because you have to convert between ones that look like this to ones that look like that, and in reverse, ones that look like this to ones that look like that. And in this case, these are 2 different constants. So if you have, for example, 7 times 3 to the x, you could turn it into 7 to the x times 3 to the x. And now what I'm going to do is I'm going to show you some examples of how this works. Oh, and one more thing is that I'm not going to pause very much in these videos, so what you should do is you should pause the video right now and look up the way to take screen caps on your laptop or phone, although I'm not sure how you would possibly see this clearly on your phone. So, I'll give you a second to do that, and then we're going to do some examples. Okay, so for these ones, what we're going to do is we're going to convert these back and forth, and all you have to do is apply the steps. I wrote the steps really small over here so you can just remember which ones they are. If you haven't yet, you should go back in the video and copy them down, or refer to your screen cap that you took. So the first, the great thing about this is that you can do these in any order. For example, you could deal with the bottom, you could deal with the combining for rule 2 first, or you could start with rule 1. For this one, you could start with rule 3 first, or, rule 3, because that's mostly rule 3, but there is rule 1. Okay, so let's start with number 1. And I'm gonna write down all the work, and then I'll explain it, just like during my office hours. Okay, so at this point, what you'll notice that I did is I went back and forth with these rules. So I turned 5 to the 3 multiplied by 5 to the x into 5 to the 3 plus x. And in this case, what I did is, it stayed the same. But for the next step was to apply rule 2, which is that you take everything on top and you subtract the exponent from the bottom. So that will give you your final answer of 5 to the power of 3 minus x. Now we'll go on to number 2. Okay, so for this one, what you'll notice is that 49 and 7 are not the same base, so technically you shouldn't be able to apply the rules to them right away. But what you can do in applying rule 3 in 2 different ways is you turn 7 to the power of x to the 8th power into 7 to the 8x, and you can turn 49 into 7 squared, or 7 to the power of 2, which allows you to apply rule 1, giving you the final answer of 7 to the power of 8x plus 2. Now, these are the very basics. So let's see what happens when you apply these rules to a more complicated problem. What you'll notice is that it works exactly the same way, however, just with more things to do. A way to help yourself with these is to not think of them as a math problem, but think of them as Sudoku. Think of it as just a puzzle that involves numbers. That's the way that I got through learning this. Okay, so here's a problem that looks a little bit more complicated, but the idea behind it is exactly the same. You just apply these rules to simplify it down. Now, like I said, you can do this in any order, which I'll demonstrate here. In this case, you can work either from the outside in or from the inside out, or any mix of the two. What I'm going to do is first I'm going to work from the outside in, and then I'll show you the way from the inside out. And you'll see that we get the same answer. Okay, so now that we have our answer, let me walk you through it step by step. Again, this is working from the outside in. The first thing you want to do is to deal with that 3. And referring to Rule 5, what you do, well, Rule 5, kind of mixed with Rule 3, is that you multiply each of the powers inside of it by that 3, as you see that I did here. Then you move to just pure Rule 3, which is that you make all the bases the same in that way. For example, 8 is the same thing as 2 to the 3rd power, and 16 is the same thing as 2 to the 4th power. And once you have it that way, then you can deal with the various parentheses, which is what I did over here. For example, 4 to the 6 is 24, or not, 4 times 6 is 24, and 3 times x times 12 is 36. So, now that you've done that, you can apply Rule 1 by putting the multiplications of the same base together in addition. So it would be -6 plus 36x and 6x plus 24 as the exponent in the bottom. After that, all you really have to do is get rid of that division. So you apply Rule 2. You take the entire top exponent here and you subtract from it the entire bottom exponent here, which gives you your final answer. Oh man, that contrast is really bad. Okay, so what I'm going to do now is I'm going to show you the way to do it from the inside out, and you'll see that we get to the exact same answer. Okay, so what you're seeing in this case is that the first thing I did is I worked from the inside out. I turned all the powers, or all the bases, sorry, into 2. Then, after that, what I did is I took those 2's and I applied the exponents on the outside of them to those. And then I did Rule 1, adding the exponentials of the 2 bases on the top and the 2 bases on the bottom together. Like so. Then I went to Rule 2, and I subtracted the exponent on the bottom from the exponent on top to get this result. And then the last step in this case was what we did first in the last time, which was we apply Rule 3, and we take all of this on the inside and multiply it by 3, getting the exact same answer. One second, let me see if I can. Man, I need some new dry or wet erase markers. And if you want to be able to see what's happening more clearly, my Venmo is in the description, and because this whiteboard was a lot of my own money to get in the first place, and I can't really, Alright, so now what I want you to do is I'm going to show you another problem, and I want you to try it on your own. Of course, I can't make you do that, but it's a way that it'll help you. And it'll really drive it home if you try it before I explain it. Okay, there's your problem. On the numerator, it's 9 to the power of 2x and 81. And the denominator, it's 27 to the negative x and 3. And all of it is raised to the power of -2. So I'm going to give you a minute to try it yourself. And what I mean is that you should pause the video now, because in a second, I'm going to write it all down and explain it. Okay, so now I'm going to do it myself to check your work. Remember, your work might look a little bit different than mine, but as long as you got to the same answer, you did it correctly, chances are. Okay, And that's all there is to it. What you'll notice is again, I just applied the rules, and you have to keep in mind that the number that you get to itself, for example, 3 itself, is considered to be the same as 3 to the 1 power, which is why I added 1 over here. Okay, so if you have any questions or you feel uncertain about this, feel free to send me an email on my UMBC email, and I can set up collaborate hours with you to help to teach you online. And we can actually go over some of these exact problems if you want. So, and again, feel free to also let me know if there's anything in the production of these videos that didn't work for you, but keep in mind that I'm paying for all this stuff with my own money, and I'm not being paid for my time because I already work the maximum of 20 hours a week, not including making these videos. Alright, thank you and see you next time.